Okay, let's make sure that we are all going down in the right direction. Can someone raise your hand and tell me what you would like to do first on this integral? Raise your hand.
I would like to make a U.
Oh, make this one U?
Yeah.
You could. If you do that, you're going to get x to the 6 plus 1. du is going to be 6x to the 5th, which kind of takes care of this one, but not this one.
Not that one.
Raise your hand, please. Yes. Yes, split it. So splitting it is probably the best idea this time. I'm going to put a negative in the front. I cannot erase it. Okay. All right, now what? What should I do on this integral that's on the left? U, just the normal U sub. What about the one on the right?
Take out the 5.
What?
Take out 5.
Take out, oh yeah, sorry. You should take out the 5. Yes, good idea.
Okay,
If we use U sub, it's still not going to work.
Use
Tangent, yes. Tangent. So how do I change that x to the 6 so that it's in the arctan form? X cubed squared. Okay, so I think that's enough hint. Yes?
For the first one, can't we just use some stuff?
Yes, that's what everyone was saying.
Oh, that doesn't work.
It does.
Oh.
Yes. Okay, so this answer is 1/6 natural log absolute value x to the 6 plus 1 minus 5/3 inverse tangent x to the 3rd plus c. All right, so next. All right. What should we do in this case? So kind of think through all the things that you have learned so far. Can I use U sub? Like really quickly think, no, it's not going to work because there's going to be an x that I can't get rid of. Can I use like inverse sine or inverse tangent?
No.
Not really. Just do it normally. What's normally? I cannot split.
Make everything U and then use natural log.
Natural log, I'm still going to have a problem with so like let's say your natural log is this, right?
There would still be a chain rule.
There will still be a chain rule with the x, so that's not going to work. Yes, Elizabeth.
Just do like x to the negative 2 plus,
Ooh, that is a bad idea. I don't know which animal it will die, but you can't move everyone up like that. They're all chained together by a plus sign,
then put that in parentheses and then to the negative 1.
which is going to become the natural log, and then like Ben said, there's going to be a chain rule, so you can't get rid of the x. Yes?
I don't.
I change to x plus 2 square and plus 1.
Oh, yes, that's what we're doing today. We're going to complete the square. So we need to complete the square so that we can solve this. All right, let's recall completing the square. So complete the square, the first thing you're going to do is group the x parts together. I'm going to just put a 1 there. Okay, so that's going to be x squared plus 4x plus blank. Oh, bless you. Okay, plus 5 minus blank dx. All right, so let's recall completing the square. So group the x's together, add a number. Since we're on the same side, you got to subtract that number out. Okay, what number goes in the box? 4. Okay, so basically b over 2 squared if you have not been practicing completing the square for the last 2 years. Okay, so b over 2 squared. All right, now this becomes 1 over x plus 2 squared plus 1.
So then.
Yes, so now inverse tangent, right? So what we're going to do is recognize that is the inverse tangent form. So u is what? X plus 2, and then du is dx. Oh, that's a very nice direct substitution. So then this is just going to be 1 over u squared plus 1 du. Oh, this is very nice. Okay, inverse tangent u plus c, which is inverse tangent x plus 2 plus c. So this is where, yes, go ahead.
So if you just see it, can you do it, or do you have to show all that U's and stuff?
What's that? Where do you want to skip?
Like everything about you. Like,
Yeah, you don't have
I
to
just
use
went straight
these.
from
Everything
X plus
about
two.
you.
Yes, you don't have to use u sub. You don't have to use u substitution. If you can see it,
Okay.
then just do it. Just know that sometimes the AP test does say, if you were to use u sub, what would u be? Or if I make u this, what would this become? So you have to know it, but if they don't specify you have to do it, you can do it any way you want.
Okay, so we actually don't have to use U?
Yeah, of course not. You just need to integrate.
That's great.
Okay, so again, this is where you kind of want to go back to all the techniques you know. So when you see something like this, first you think u sub. U sub does not work, then you think of other things, maybe tangent. And then if all that doesn't work, then you can start thinking completing the square. Okay, so we're going to complete the square for the most part today. Let's try another one. This one. This one's a little bit trickier, so let's kind of do them together. Or I'm going to help you halfway, and then you can finish. Okay, 1 over x squared minus 6x plus blank plus 13 minus blank dx. What goes inside the blank? Good. All right. Factor and simplify. So this is going to be 1 over x minus 3 squared plus 4 dx. Okay, notice that I am not adding 1 at the end, so this is not a perfect arctan form. Divide by 4, or another way to think about it is factor out the 4. Because we can't actually get rid of that 4. So yes, we gotta get rid of that 4 by factoring. Ooh, bless you. Too close to Jaden. Okay, so factor out the 4, so that's gonna be x minus 3 squared over 4 plus 1. So what I did was just kind of factor out the 4 from both terms.
Don't you just take it out completely though?
One.
Sorry, say that again?
1/4?
Yeah, eventually, yes.
Oh.
So then you have to take the 2 and make like
Yes,
squared.
so now I have to make this part a something squared. It cannot be a square over a number. So, okay, so first, like Elizabeth said, take all the coefficients out. So I'm going to take that whole 1/4 out. Makes the integral a little simpler. And then, like Zach said, we're going to make this a x minus 3 over 2 squared plus 1 dx. All right, I'm going to leave it there. You guys finish, and let me know when you're done. All right, so let's finish this one. U is equal to x minus 3 over 2. So du is going to be 1/2 dx. We don't want that 1/2, so multiply by 2. 2 du is equal to dx. So bring all the constants or coefficients in the front. So 2 over 4. 1 integral of 1 over u squared plus 1 du. So this becomes 1/2. And that integral is inverse tangent u plus c, which is 1/2 inverse tangent x minus 3 over 2 plus c. All right, let's try a few more. This one is going to get a little bit trickier. Here you go. Okay, the answer is square root 3 over 3 inverse tangent of x minus 2 over square root 3 plus c. All right, let's try one more. Now we're going to go into inverse sine.
What?
Okay, and there are limits, so that means you need to evaluate the area. Okay, inverse sign. Remember, inverse sign is square root of 1 minus x squared, or 1 minus u squared. So it's a little tricky. I can't, for some reason, I can't complete square backwards. It makes me feel a little bit scared when the negative is in front of the highest exponent. So my mind gets stuck. So I take out the negative. I'm sorry, that should be a negative. And then plus blank. And then minus blank, right? But the leading coefficient is negative. So that should be plus. Are you guys with me?
Yeah.
Usually you add a number, you subtract it out, but the leading coefficient is negative in this case, so you actually have to add it back. So please be careful when the leading coefficient is not 1. You gotta do something there. Okay, what goes inside the box?
1.
Uh-huh. All right. Okay, simplify. 1 over square root of negative x minus 1 squared plus 1. Yes?
So for any negative leading coefficient, it has to be plus on the end, and if it's any positive leading coefficient, it's
Yes.
Yeah, if you have something bigger, then you have to multiply it.
Yeah, correct. All right, so this is going to be the inverse sign form, which means that this is actually kind of in the backwards way. So this is, I'm going to rewrite this. 1 minus x minus 1 squared, and then dx. Okay, so go ahead and solve this one. You're going to evaluate. So if you're in u, please make sure you change the limits.
Oh.
If you are in x, you don't have to change it. Okay? Okay, so first, once you integrate, the answer is inverse sign of u, and you change the limit, so the limit is from 0 to 1. So then evaluate, you get inverse sign of 1 minus inverse sign of 0. Inverse sign of 1 is pi over 2. You gotta remember unit circle. And what inverse functions mean? Inverse sign of 0 is 0, so pi over 2.